Welcome back to Further Solutions Academy. Further Solutions Academy. I encourage us more to share our video, subscribe if you have not subscribed before, kindly do that, and also leave a comment before you leave. Just drop your comments for for motivation, for moderation and other things. And just in case you want to reach us, you can comment below, or you make use of this line. Now, with this line, you can do three things. You can call us, you can WhatsApp us with this line, and also via Telegram is also allowed, either of the three. You can, on this video, I'll be walking you on continuity, which is on topological space. We have been on topological space, and this is another video on topological space, which is on continuity. Now, by the end of this video, you understand what is called continuity on what? Topological space. Okay, by now, you should know what is called topology. You should know what is called, power set. You should know bases, because we have done all those things in our channel. You should know what is called and so on. And we have a lot of videos on this thing. You can also move on with it, and you'll be fine with it. Okay, by the end of this video, you will understand the meaning and the concept, and including example of continuity. Now, look at this problem. Okay, before we talk about problem, let's talk about the definition of continuity. Okay, now look at this definition. Okay, look at this definition. Let S and Y be a topological space. A function, this is the function f to y, f of s to y, is continuous if the inverse of that v is open in S for every open set v in y. That is what I mean by that. Now, we call this the open set definition of continuity. Okay, the statement that f is continuous if the pre-image, what is called image and pre-image, back to your mapping, if the image of every open set is open. That is what I'm trying to do. If the image of every set, pre-image of every set is what is open. I think when we talk about mapping, we have we have image and pre-image. Okay, now let's see. With the help of example, this will be understood very well. Now look at this. Look at this example, because I have to manage the board at this point because of the space. Okay, now look at this example. Oh, look at this problem. It's a very good one. What you have here is another way of presenting topological on each of the sets. Now, because we are talking about x and y, now this is another way of presenting topological space. What I'm trying to do here is that this one will be A, this one will be B, C, and D. That is all. Here will be 1, here will be 2, here will be 3. They are just another way of presenting it. Now, if I have this type of problem, I want to find which of them are continuous. Which of these people is what? Is continuous. How do I go about it? Now, solution to this problem. Solution is very simple to solve. But what I need to do is that the first thing I will do is by making the topology to be real. How do I make it? I know this is my x, this is my y. I think I will move on to, okay, let me first start with my x. My x is A, B, C, D. That is my x. And my y is also given as 1, 2, 3. That is my y. Now, I will move on to the next thing, which is I need to generate my what? So that you'll be able to understand, list out the topology on x, how do I go? This one, I will be talking about empty. Okay, I'll be talking about x himself. Okay, x himself. Okay, what else I need to work on? At this point, I have this is okay. I have this is C, singleton set. This one is a singleton set. I have C. Can you see? Because it's on its own, and also this also is two sets, which is going to be what? AB. Now that is for this bracket. And what X? I have CD. What X? I've done that. That is that. And I have ABC. Now, can you see another way of generating my what? And the X is already given to you. That is all about that. Now, if I should work on the Y part, it means my Y part, it means topology on Y will be equals to what else I need to do. The first thing I need to do here is that I have the empty, I have Y himself, and I have 1 is a singleton test. I have a set. I have 2 is also a singleton test. I mean set. I have 1, 2, and the last one is going to be Y, which is we have done that. Now, by so doing that, successfully I've generated my what? The topology from the diagram. That is how to generate the topology from the what? From the diagram. By so doing that, I can now continue what I want to do. The first thing I will first check here, to check that a function is continuous, we have to verify the pre-image on each open set in Y is open in what? In X. By saying that, let me take the first one, which is going to be on my let me take F, function F. Now this is my function F, because there are 3 functions here. We have F, G, H, and it's listed on the question. You know, we have F, we have G, we have H. Now I'm taking the first one, which is my function X. Now my function F is what I'm taking now. I will move on by F of my A is 1, F of my B is also 1, F of my C is 2, F of my D is also 2. Now, that is very correct. Now, I will now say that what? A, B, C, D. A, B, C, D. Because these are the what? Now, are from X. They are from all X. Take note of that. And 1, 1, 2, 2 are from Y. Since I know that that is from X and that is from Y, now I will now look for it and say that what? I have 1 and I have 2. These are the 2 sets given to me, which are open in Y, because 1 and 2 are open in 1 and 2 is open here. That is the open set of this. Now, since they are open, it means this is open. What else I'll need to do? It means the pre-image of A and B, it means pre-image of function inverse of B, of A, function inverse of 1, sorry, it will be equals to what? A and B. Now, it will be equals to A and B, which A and B are in what? Are in X. A and B are in X. A and B are in X. Can you see? They are in X. Since they are in X, I'll move on to the next one. Inverse function of 2. This is how to indicate that it will be equals to 2. We are talking about 2 give us C and D, C and D, C, comma D. Now C, comma D are also C, comma D are also in what? Topological space of X. They are also topological space on what? On X. Since that happened, it means F is continuous. F is what? F is continuous. F is continuous because the pre-image of each open set in Y is open in X. The pre-image of, because the pre-image of the pre-image of each open set in Y is also open in X. That is all about that. It means, can you see how to generate? It means by so doing that, my F is continuous. My function F is what? Is continuous. Please take note of this very well. Let me go to the next function. That is how, because of my space, I'm supposed to be able to, to show this very well. But due to space, I have to manage. Permit me to manage my board. We need sponsor at this point, no amount small. If you want to contribute. Okay, that is the conclusion for F. Now, let's move on to the next function, which is, this is my F. Now, I want to move on to the next function, which is going to be my G. I'm taking what? Working towards G now. I want to work on G. This is my G. I will move on to G of A equals to 2. G of B equals to 2. G of C equals to 2. And G of D equals to 3. Now, can you see? I just listed those things out. Now, I will now move on by having G. We have 2, 2. And now, it means G of, this is 1. This one's supposed to be 1. I don't want that to happen. This is supposed to be 1. This is 1. Sorry. G of C is 1. Sorry for that mistake. Now, it means since I have that, I will now move on by having my G inverse of 2 will be equals to, the G inverse of 2 are A and B. AB. Now, AB is in what? Is in topological space of what? Of X. That is very, very important. I'll move on to the next one, which is G inverse of 1. Inverse of. It also be equals to, which one produce 1 is C. And C is in topological space of what? Of X. Okay. I will move on to the last one. G inverse of 3 now is what? Is D. Since D is not in, we can see that 3. Okay, D is not in what? In X. Can you see D is not in X? Can we see D there? What is here? Is there anything D here? No, nothing. It means it's not in there. Now, okay, with what we have done now, D, note that D is not open in what? Not open. Just say not open. Let me put a word not open. In X. Not open in X. Okay, since it's not open in Hex, yes, is not open in X, and also 3 not open in Y. 3 not open in Y. Both of them are not open. Now, since that happened, okay, you can see that both of them, both D and 3 are not open. You know, the statement contradicts each other. It means what I will say that what? Hence, G is continuous. G is what? Continuous, since pre-image of each open set is in Y, and is in X, is in Y and X. That is what we mean. Since that is happening, it means G is what? Is continuous. G is continuous. Now, let me move on to the last function. Let's check, maybe it's also continuous. Let's move on to the last one, which is going to be H. Now, let us talk about H. Now, look at H. Look at H function. I will pick up my H. What are my H function? I have my HE equals to 1, HB equals to 2, HC equals to, and HD equals to 3. Since I have that, 1, 2, 3, yes, okay, yes. Now, I will now move on by having my H inverse of that one, first one, which is going to be what? Is only singleton test of A. And A is in what? Is in X, topological space of X. And I move on to the next one, H inverse of 2 is BC. Now, is BC. BC not in what? Not in what? Topological space of X. Is not, because there's nothing like that here. BC, no. There's no BC. I'll move on to the last one, which is going to be what? My H inverse of D. My H inverse of what? Of D is what? Is going to be H inverse of D. Of 3 rather. Sorry, mistake. Of 3 is D. Now, since is this, and note that 3 is not open in Y. Is there any 3 in Y? No. And 3 is not open in Y, and also this is not opening in this. It means you can see that since that happened, these two things contradict the statement. It means H is not continuous. H is not continuous. It means H is not continuous. H is not continuous because 2 is okay. If I want to put H is not continuous because, let me put because 2 is not open in Y, and but okay, sorry, let me put the word but G inverse of 2 is, G inverse of 2 equals to what? BC is not open in in X also. Can you see? That is why that is not what? Continuous. By so doing that, we have solved all we need to do. By now, you should understand the meaning of what. Can you see? F is continuous. The pre-image of each open set in in Y, is also open in what? That is very one, which we have done that. And the second one is what? G is continuous. G is continuous, which because I've given you the previous the system then, and H is not what? Continuous because of what? 2 is not open in Y, but H inverse also not open in what? That is why it's not continuous. I will be stopping here. Don't forget you are home with Further Solutions Academy. Kindly share to your friends, subscribe if you have not subscribed before. Once again, thanks for watching.